So, everybody got the address? fitslab.shinyapps.io/city app, no space. And it's super simple. What this does is it took two of the many sort of forward-looking scenarios that climate researchers and planetary life support researchers have been sort of working on for the past 25 years and sort of continuously refining. And for each of the top, I think it's 500 cities by population in the United States, they took a look at what's the current climate of this place, what's the current climate of all of the other 500, and run the clock forward 60 years to 2080, and then figure out for whatever particular city, what is that 2080 climate going to be like in terms of 2023 climate conditions of some other city. So, for example, for our favorite town, the Dirty Dale, Carbon Vegas, under a sort of current high emissions, a business as usual scenario, RCP 8.5. That is, you know, if we get a little bit of half-hearted climate effort and action and legislation, and if, you know, some people eventually kind of switch over to battery electric cars, and maybe we eat like one or two fewer Big Macs a year, less beef, stuff like that. Try to buy a little bit more local. You know, like how's that going to go for us? In addition to our population continuing to grow for a while, and so on and so forth. So you throw all those variables together into these huge, incredibly detailed climate models, and you just start running the clock forward, and you see what happens. Okay? So under a business as usual, our current high emissions scenario, as it's called, which our actual sort of monitoring data are most closely tracking with, right? There's all sorts of, well, if we stopped emitting everything tomorrow, how would things go, right? That's an interesting thought exercise, but it's not realistic. We're not going to stop driving our cars tomorrow, and so on and so forth. So this is our best guess of how things are actually going to go in 2080. So 60 years from now, what those models show is with really pretty high confidence, the most analogous current U.S. city that Carbondale will feel like in 2080 is going to be somewhere between Baton Rouge, Louisiana, and central Oklahoma. Okay, so the specific town is called Monroe, Louisiana, and then it gives you a few stats for this particular town elsewhere. So it's going to be 5.1 degrees Fahrenheit warmer and 3% drier than summers in Carbondale. Okay? Not a huge change, but average change of 5 degrees Fahrenheit is some pretty big spikes above and below 5 degrees. So think crazier winter storms, much more intense summers, occasional heat domes, and stuff like that. Okay? So they also break out what are the 27 most similar current climates to what Carbondale's climate is going to be like, where your national park's nearest city climate is going to be like in 60 years at 2080. Okay? So, we're most like northern central Louisiana and northern Texas, southern Oklahoma. For those of you who have been through northern Texas and southern Oklahoma, you're never going to get those entire days back of the driving that you had to do to get from one side to the other. But think about in your mind's eye how different the vibe was in northern Texas versus in Carbondale, climate-wise. That's what managing the Shawnee National Forest, for our purposes for this scenario or this exercise, that's what it's going to be like to manage the Shawnee in a Oklahoman climate. Or right outside of Phoenix, Arizona, like the southwestern desert. Phoenix had a whole bunch of days where the temperature never got below 100 degrees, and some of your fellow Americans died of heat. So in 60 years, died of heat this year in Phoenix. So in 60 years, as this kind of ecotype marches north and east towards us, that's what we're staring down the barrel of on the Shawnee. Because we can't, as in the Shawnee's case, forest protection officers and district foresters and forest supervisors and stuff like that, we don't have any direct control over the emissions today of everybody building stuff in China and India and driving Hummers in the United States when they don't really need to be driving Hummer, but oh man, it sure would be cool, right? Getting like 3 miles to the gallon or whatever they get. So, our higher carbon lifestyle is going to shape how you do forestry and park management for the next 60 years, for essentially the rest of your life. All right, you guys will be about 80 years old by that point. So, give me your town or some American city that is close to your national park. We'll pull it up and see what we can find. Anybody?
Michigan City.
Michigan City. All right.
Yeah, Michigan.
Michigan City, Indiana. Let's see if it's in here. Michigan City, Indiana. Okay. So, the southern tip of the Great Lakes is going to have a climate most like northern central Oklahoma, or kind of northeastern Arkansas, right? So kind of hotter, kind of more humid, right? So you've all heard the political expression draining the swamp, right? Washington, D.C. was partially built on a filled-in swamp down by the National Mall and stuff like that. So kind of the question lurking underneath this data for us is how your park, how it's currently being managed, can it even be the same national park in 60 years? Assuming that human nature is what it is, we're not going to change the kind of people that we are. Largely speaking, we're generally not in a hurry, apparently, to change to a more sort of globally sustainable lifestyle. So can your park, years from now, 60 years from now, within your lifetime, survive as the park it is recognizably today? Can you manage it to a central Oklahoma climate regime? Or not? So, we're talking about an existential threat kind of a question. Okay. If the pendulum swings for the Shawnee National Forest towards the weather of Phoenix, Arizona, it's game over, right? We're going to have to figure out something else. Like, that's not a forest that we can keep as a forest as is under that system. Okay? So, this is not to say that we're all going to die. The planet is on fire. But there's a lot we can do, and there's a lot that a lot of people are doing, okay? But we need to not shrink back from taking a clear-eyed look at the very best data that we have so that we can make some responsible decisions. Okay. Cool. All right. Anybody else? Yeah.
Colorado Springs.
Colorado Springs, a wonderful and expensive place to live. Colorado Springs. Did I scroll that? Ah. There we go. Not as much of a dramatic shift for Colorado Springs. Okay. So it will be as though you're kind of looking for the center of mass across these different sort of scatter plot locations. So somewhere around here, we're going up a couple of degrees of latitude. Not terrible. Okay. Cool. Anybody else? If you got it pulled up on your phone, you're fine. Good to go.
Probably Cape.
Say again, Cape Girardeau? Okay.
I think that'd be the closest that's on that map.
All right. On the outside, you're looking at the very hot and somewhat more dry, but with more intensified storms regime of College Station, Texas. But more likely, looking at sort of somewhere around maybe like Shreveport, kind of the Arkansas, Louisiana border, right? So a couple states south, importing that weather north, that climate north. Anybody else?
Farmington.
Farmington. Farmington, New Mexico. What if it's just Mexico in 60 years? Have you ever been down close to the border?
No.
It is hot and dry. Oh my goodness. Hot and dry. St. George, Utah is in the middle of the desert. There's a bunch of desert tortoise habitat right there, like right there, and some like national preserve lands and stuff like that. It's also the fastest growing urban area in the United States, and they don't have any water. Like, somebody should have thought of that, but not so much. All right, so kind of center a mass across this band somewhere around here. So southern Oklahoma, imported to a northern New Mexico setup. Northern New Mexico already pretty dry. So add more dryness to that sort of redstone, that tableland, that mesa country type area. Mesa Verde National Park is very close to right there. All right. And how's that gonna go? Yeah.
Out of curiosity, can
Yeah.
you do Death Valley?
Death Valley. I don't know if Death Valley is one of the cities, but we'll be close to it.
Close.
Let's see.
Wouldn't it be a little left from Vegas?
Would it be Vegas? It's not.
Closer to
Or
the-
Carson City?
Closer to with a P next to Vegas. That's probably closest.
Pahrump. It's an unfortunate name. Not a whole lot different. All right. Cool. So, not a whole lot different. A little bit hotter. So the typical summer, if for the closest fit exemplar city for 60 years at Death Valley, 10.1 degrees Fahrenheit hotter and 0.5% wetter than summer in Pahrump, Nevada. Cool. All right, any others? Michael.
Missoula, the one that's kind of neat is, what is this? Wazila and
Alaska?
Alaska, yeah.
Let's see. Helena, Missoula. Here we go. I almost went to grad school in Missoula. Nice place. All right. Looking at a 10.9 degree jump in temperature and 3.2% drier than winter in Missoula. Here is the individual breakout. Wow, it's pretty dramatic. Usually what we're going to see is the farther north something is in the northern hemisphere, so higher latitude, is going to have a longer stretch between the current location and its future climate exemplars. Okay, so looking at somewhere around here, moving that north and east. So Missoula is close to which national park? The one with lots of ice?
Yeah.
Glacier, right? So if we crank up the average temperature 11 degrees at Glacier National Park, like what do you call it when there's no more glaciers left? Because you can't cook glaciers at 11 degrees hotter for real long until there's just not any glaciers anymore. Okay, so this is the kind of situation that we're quite honestly facing, right? This is what we are buying when we buy stuff, when we eat, when we travel by plane, all the things that we do as Americans. We have a pretty tiny fraction of the global population, but the United States uses about 1/6 of the entire world's energy budget. We live real high on the hog. So this is on us, not us in this room specifically, on all of us, okay? We are leading the charge the wrong direction, so to speak, as Americans. All right, I love my country, and it is a patriotic thing to want it to exist past the year 2080. Cool. So, that is our event. The climate responds to how we treat it. Okay? So, we have our same 4-step process. The event. Let's just turn this off for a sec. There we go. So, again, what is the event? Climate change. Impacts. Impacts to the physical natural resources of your park. Impacts to the experiential resources of your park. The opportunities that people have to come and enjoy your place that you're working so hard to run. Economic impacts. Larger scale regional ecological impacts. What's your plan? What's your response? For this particular one, in this particular scenario, we're going to lean pretty heavily on the plan part of it because we got 60 years. That's a long time. Like, that's 3 whole generations of human beings. About every 20 or so years, we kind of turn over into a new generation. Boomer to Gen X to Millennial to Zoomer to whoever's after that, right? Okay. And fourth and finally, how's this gonna go? Now, this is kind of an unfair question for a professor to spring on a bunch of students because this is super complex, isn't it? So what we're going to do is limit ourselves to just that climate shift projection. Okay? We're not going to be too optimistic and say the world is magically going to rapidly avert climate shifts. And we're not going to be too pessimistic and say, well, it doesn't matter, we're all going to be dead by then anyway. We're going to go straight down the middle with our best understanding, with our most highly calibrated models, validated models, and figure out where we're aiming for and put together our plan. Okay? So, what we're not worrying about are things like Arctic summer sea ice loss, or Antarctic ice shelf melting or sloughing off into the ocean and raising the entire global ocean by meters and meters. Okay? We're not worried about the Atlantic Meridional Overturning Current, the AMOC, slowing down about 16% since 1950. So millions and millions and millions of cubic miles of seawater flowing about 1/6 slower than they used to as a result of climate change. We're not worried about, well, maybe we are worried about wildfires. Maybe we are worried about ticks showing up in moose habitat where they weren't so bad before, showing up so badly that they literally drain the moose of their blood and the moose die. This is something that's already happening. Okay, so wildlife impacts. With that temperature shifting range, we're going to import all of those species as well. Right? So the tropical mosquito vectored illnesses that are pretty much showing up in like Floridian national parks, bone-breaking fever, chikungunya, Zika, West Nile virus, stuff like that, that makes a lot of people sick, kills a few people, that sort of thing. Right, the range of where we're seeing people get that stuff is just sort of marching north and west up and out of Florida through Georgia and Mississippi and Alabama and moving our way. Same thing with tick habitat. It's just sort of moving up and over. Okay. All right, so if you're just getting here, our scenario is the climate changes. Kind of how it already is, but we're sort of running the clock forward to about 2080 to figure out our best guess on how it's actually going to go. So we're using the business as usual scenario. And did you have a chance to look this up on yours? Okay, we'll look it up now. It's no big deal. We got you covered. All right, what's the nearest city to your park, White Sands?
Can't remember how to pronounce it. Let me look at the spell.
Amarillo by morning.
It's like Almorago. ALAMOGORDO.
Alamogordo. Alamogo, that's not on our list. Let's see.
La Cruz. LASC. Or
Las Cruces?
Yeah.
This map is only loaded with the largest 500 cities. Here we go, Las Cruces. Okay, cool. All right, so Las Cruces is here, and 60 years from now in 2080, the climate in Las Cruces will be replaced by these. Okay, so that's like northern central Mexico, as far south and west as Sonora, Mexico. So like classical desert-looking Mexico, tumbleweeds and stuff. Tucson and Phoenix area, very, very hot, very dry. So mostly moving west, or eastward and north. If we want to pick the average across those, you're looking at a 12-degree average temperature increase in Fahrenheit and 35% drier. So we're talking major, major structural overhaul, renovation, wholesale destruction of the local current ecosystem in White Sands. Okay. Yeah.
Can I do my part too? I
Yeah,
think,
sure.
Maybe Olympia, Washington. is on the map.
Olympia. Let's see here.
Where the dot is on the peninsula. Oh,
This one here? No.
yeah, I'll get the closest.
This one here?
Sure.
That checks out. Maybe Victoria. We could do both. All right. Might be halfway dodging the bullet here. 5.1 degrees Fahrenheit increase. You're so close to the thermal mass of the Pacific that it's going to be a pretty big moderating factor there. 24.6% drier than winter in Sequim, however you say that. Let's also try Vancouver, a beautiful place. And Vancouver feels to me a lot like the peninsula in Washington, so. Yeah, 2.6 degrees warmer and 33.5% drier than summer in Vancouver. So Pretty big shift, right? So this is temperate rainforest out here. This is a very different vibe, forest structure, ecosystem dynamics-wise, than what we're used to here in the temperate and sort of moderate rainfall Midwest. This is literally a rainforest, but it's higher latitude than we are. Pretty cool stuff. It's a beautiful, beautiful place. Vancouver is this bright, vibrant green almost year-round. Everything just grows like crazy up there. Okay. Any other questions on that? All right, cool. Everybody got your notes on what your park's climate shift is going to look like, most likely? That's good. Cool. All right. That's the event. Climate shift. The impacts are those numbers. X degrees hotter, Y% drier or wetter. Some of the models have the Carbondale area here becoming something like 15-16%, so 1/6 wetter in terms of overall annual precip. Unfortunately, a lot of that's going to be in more intensified storms. We're going to lose a lot of soil, but you know, more water could help in a hotter, drier, angrier climate. Okay? Cool. So, for impacts, we are thinking about non-native invasive species, both vegetative and wildlife, sessile and motile respectively. So stationary and moving. Things like parasites, ticks. Things like insect vectored illnesses, again, chikungunya, bone-breaking fever, Zika, stuff like that. If any of you are video game fans and watched the recent award-winning TV show, The Last of Us, right? This was a tropical fungal parasite, essentially cordyceps type fungus, sort of the zombie fungus that currently only parasitizes like ants and stuff like that, but in the video game, the fictive universe, jumps to humans. Fungal infections are going to be more of an issue, and we don't have a huge range of antifungal medications that don't also generally kill the patient. So that's something to keep an eye on in the next 60 years. It's all very exciting. Okay. Other impacts. If your area is going to be drier, what's your fuel loading like? Are you looking at, some catastrophic wildfires blowing through every once in a while? Because there's less rainfall to help sort of cool that off, slow it down, spread out those fire events? Or is it a drying out tinderbox? If your park has cryo resources like Michael's does at Glacier National Park, that's going to be really pretty different at a lot of these places, especially the farther north we look. Okay. Other impacts. Climate destabilization also has human social effects. So, for example, when we look to examples of what things or how things kind of play out when the climate starts breaking down in other places that have a little bit more pressure on them in terms of population relative to food supply and stuff like that. We see things like this article from The Guardian a couple of years ago. Believe it or not, when you stretch people to the edge of survival, things like violence against women shoots up, okay? So we want to think about what are some of the direct human consequences of a hotter, drier, more infested, destabilized system. Okay. So think about droughts as well. Yeah.
Is this isolated to like climate change, or is this like any like stressful global event?
Any stressful global event, but for most like regional scale stressful events, the entire rest of the globe can kind of absorb some of those problems. So for example, the migrant crisis or the refugee crisis at America's southern border, or the hundreds and hundreds and hundreds of people drowning like all the time trying to cross the Mediterranean to get from drought and war-torn northern Africa to European Union states, like it's kind of okay, right? So it's a lot more people than any of these countries are geared to expect or prepared for to receive. And so you see, political machinations back and forth. We gotta build a wall. No, we gotta treat these people like human beings. They're refugees. Like, we mostly cause the climate destabilization and the political regime destabilization that is causing people to migrate and flee up toward us. And sort of the promise of fairer and freer survival. But with climate change, there's no other place to go, right? So the stressors are all around. So the global scale of it changes the ability of the response quite a bit. For example, let's see, let's take a look at a couple of these wildfire examples. This is, can you hit the lights there, please? Thank you. I appreciate it, Lydia. So this is space-based, so NASA observation of 2020 wildfires in Oregon. Like, those are big fires, big enough to cover like almost double digits of the total landmass of that whole ass big western state, right? But the bigger impact, the one that nobody can kind of get away from, is the smoke plume, right? So the fires themselves are necessarily basically contained to whatever nation and state they're in, but once we shift over to the day part of this cycle, look at that. Like, that's going all the way across the thousands of miles of the Pacific Ocean and smoking people out, and not in the cool way, right? So the issue is when a stressor is widespread or ubiquitous across the entire planet, we have way less capacity to respond to care for refugees, for example, because we're the refugees too. Does that make sense? So hopefully that answers your question about other kinds of stressors. So with the jet stream starting to weaken and tilt across the surface of the Earth, we get polar vortices. These, normally that super cold air at the top of the planet, up here, that's like super cooled Arctic air. That is really, really, really cold air. And the jet stream is a 500, 600, 700 mile an hour circumglobal wind that acts as kind of a fence around that. So as we change wind patterns, that jet stream is starting to wobble more and more and more. And so if you like picked up a whirlpooling bathtub, for example, if you like pulled out the stopper and it was draining and spinning and stuff like that, and then you also started like shaking the tub, you'd get a whole bunch of water splashing out. And so these very, very hot red sections of air get pushed out of the way by super dense, very cold air, the Arctic or polar vortex, okay? Or that burp or splash of that super cold, super dense air just shoves all the sort of normal hot air covering the rest of the planet out of the way. And out of the way means, in some cases, I'll play this animation again, it goes back up behind the polar vortex and superheats the Arctic, the global Arctic environment, right? So we get temperature anomalies in the Arctic of, most recently we saw stuff up to 70 degrees hotter than normal. 7-0. If we added 70 degrees to our wintertime temperature here, right? It's 45, 50 degrees today. It'd be like December 7th and it's 120 degrees out, right? Like catastrophic problems. Not permanent. Like this is a very sloshing dynamic system, but we should never be getting 70 degree temperature fluctuations. All right, so watch the red air. It gets pushed up in as that's a splash, that white part coming down out of where it should normally be. Okay? So it's a little bit hard to see until you kind of train your eye to look for it, but polar vortexes or vortices, pretty big deal. Let's see if there's another way to illustrate that well. Well, here's what the backside of a polar vortex can look like. This is what happens to all of the fish in Alaska, or can happen to all the fish in Alaska, when it gets too hot. Right? So there's a tipping point biologically. There's not enough dissolved oxygen in the water. As water heats up, it's like heating up a can of Coca-Cola. It goes flat. There's nothing for them to breathe, and they all die all at once by suffocating to death, oddly enough. And it's a pretty horrible thing. It's pretty objectionable. You can imagine the smell, but also the devastating consequences to Native Alaskans who, you know, literally their culture is built around specific salmon runs on specific rivers, right? Showing up in their creation mythos and their sort of geopolitical internal structure, right? So when everybody else's missions kills off their primary food source and a rooting element of their culture, that's a problem. Okay? Stuff like that. Let's see. A good image of South America over 100 degrees during the global south winter. Hang on. No. I have the quantitative data if you guys want to take a look at that. Anyway, yeah, so that is another thing to pay attention to. Polar vortexes, stuff like that. So, Michael, for your impacts resulting from these climate events, you would want to put in some catastrophic winter storms ironically as well. Right? When you get that big burp of cold air, you get that as far south as places like the Grand Canyon. So I can dump a bunch of snow in May or June, for example. I probably got some videos of that in here. Yeah, here we go. These are the last day of May at the Grand Canyon. The previous time we were there, it was 125 degrees, same week of the year, and it was snowing the day before June there as a result of a polar vortex. And the students were so pissed at me. They were like, we'll never financially recover from this park. Our disappointment is immeasurable and our day is ruined. Right? So, are your visitors expecting snow in May and June? It's going to happen more, for a while at least. Normally at this time of year, this place is literally crawling with 25,000 visitors at a time. And you can't find anybody there now. Everybody's bunkered up in the lodges and stuff, cursing each other and paying $10 for a hot chocolate. Yeah, rough. Anyway. All right, it's not all doom and gloom. No, it's okay. It's okay. So yeah. All right, what questions do you guys and gals have about different climate impacts, maybe relative to your region of the United States, for example, as a proxy for your specific national park? So here, Michael, we're doing just climate today for our sort of final exercise, our final scenario here, because climate kind of forces everything else a little bit more loud. So climate change is our impact, or our event. We're talking through some of the impacts together now. And if you guys have any ideas or questions, now's a good time to cover those. And then we'll move into the kind of the plan and response. What could you do about this planetary forcing at your national park? To respond to it, to plan for it, we've got about 60 years. Yeah.
I kind of went into it with the angle of like rebranding. Specifically with Glacier. Is that like an aspect you want us to try and cover?
That can be part of your plan. Yeah. So in the Forestry 220 Intro to Forest Recreation class, we talked about how pretty much exactly 100 years ago, or 105 years ago or so, we didn't have a national park system. Like, we hadn't invented that yet. We had a couple of national parks that Congress had just sort of created piecemeal and sent a couple of poor individual bastards like Harry Yount out to try and manage, like one person managing the Yellowstone in the winter, one guy, and giving up promptly the next spring. And then they send in the cavalry because cavalry is able to operate out in extended maneuvers in places that aren't developed, like national parks at that time. So all that to say, 100 years ago, we didn't know what parks or park systems should really look like or be or how they should behave. 150 years later, in 2060, well, if it's going to be different, then maybe we can make our parks different. Maybe not. Maybe that's a terrible idea. I don't know. Okay, so if it's a great idea, that part of it's going to show up in step 4, our outcomes. How's that going to work out for you, right? How's that working for you? And if it's a terrible idea, we'll be able to see that in the outcome section, right? So there's no specific single right answer to this, right? These are big, open questions that very smart people are dedicating their entire lives to working on. So you're not on the hook to get it all perfectly figured out today, right? But we do need to think about it. We do need to look in a clear-eyed way forward and set our plan. Question?
So they measured, or like they used to use like ice coring to track like the amount of like carbon in the atmosphere and
Yep.
like judge that off with like climate change or for climate change.
Yep.
But then I saw something that like disproved it. How do they do it now? Or do they use like some more technology with ice coring and more science stuff, or what's going on with that?
That's a great question. So what you're asking about is paleoclimate evaluation. So we use things like pollen cores, pond sediment. You just drill down and suck out a column of mud, and the species indicated by the pollen gives you a pretty good sense of what was able to grow in whatever climate was present, within the past 10, 15,000 years to fairly high resolution, right? There's a layer of pond sediment for pretty much each year. And you carbon date it and figure out how old it is. Ice core measurements are still absolutely a thing. They just drill out a core of ice instead of mud and basically syringe out individual gas bubbles in that column and do the same thing. So they're looking directly, that's a direct measurement of climate trapped as an air bubble in that snow and then compacted down to ice later on. So if you saw that sort of it's not a particularly controversial technique. If you saw that disproven, check the sources on that. It's a fairly common technique to try to call kind of basic science like that. I mean, gas chromatography it's decades old. It's not a weird or exotic technique at all. You just squirt that little gas bubble into the machine and it spits out what's in there in terms of how much carbon dioxide versus other stuff, whatever. So, yeah. We also do stuff like looking at lichen, for example. Lichen grow at very specific rates at specific latitudes and specific compositions of lichen communities. And the way that they grow and the rate that they grow and where they grow has a lot to do with the larger scale climate within that time. Some of it's very, very slow growing, so you can get some pretty good information out of it in that way. We also do some more, it's a little bit more indirect, but for example, the water chemistry of crystals, so evaporite minerals in caves. As ocean levels rise and fall, seaside caves record the climate of that time based on the kinds of crystals that can form in a hot climate or a colder climate with less carbon, or a hotter climate with less carbon, or a colder climate with more carbon, stuff like that, right? So the conditions of the reaction basically force that and only that reaction to happen, or the conditions steer a different crystal type to form, for example. So by going to seaside caves all over the world and chipping some of those off and analyzing them in a lab, you can figure out, okay, when this crystal formed, based on radiocarbon dating, and the kind of crystal that formed, this is what the climate had to have been in this area at that time, because there's no other way for this crystal to form. So, stuff like that. There's a lot of ways to reverse engineer old climate. It's really cool stuff.
I don't even know how to plan for the additional changes.
Say again?
I don't even know how to start to plan for it.
Okay. So let's talk about that. If you guys have any other questions or thought about impact, we can always go back to it as well. Let's see here. All right, so we've got a timeline of $2080. I'll use 2020 just to keep the math a little bit clearer, so 60 years. And we know in pretty detailed ways, like you guys have been busy compiling this stuff all semester long, we know the state of things here. And we have a very, very clear and precise set of recent climate records back to, with global extent, back to about 1880, 1890. By that point, the age of sail and then the age of steam had sort of moved scientific instrumentation all around the world to the point that different weather stations, different government offices and stuff like that were taking continuous and reliable temperature and weather records really kind of all over the place, and so we compile those together. So we know, back up to this point, kind of the very, very tight trajectory of stuff. Now, from 2023 now, onward to 2080, we're doing what's called extrapolation. So, extrapolation is where if I've got 5 dots, 5 years of data, for example, and I connect the dots, and I keep going in the same direction that the dots are connected, I can be pretty clear about what dot 6 is gonna look like, where it's gonna be, how that's going to go, right? So, near-term extrapolation, pretty easy. It gets a little bit harder when we're trying to forecast forward 60 years instead of one, right? So, we're not extrapolating a single line, we're extrapolating a cone. And as we get better and better at this modeling, as we basically some of the researchers are doing stuff like hooking together 5 to 10,000 PS5s, for example, for a supercomputing grid, and running these climate models on them, and not doing sort of a coarse, okay, the whole planet is 1 pixel. You have 1 kilometer by 1 kilometer pixels across the entire surface of the planet and out up through the atmosphere, which you have to also model as well, of course. So with that, you run millions of kilometer by kilometer across the entire surface of the Earth, hundreds of years into the future to see the trajectory of stuff. And you also have it run backwards. Rewind the clock artificially to see, okay, if this model has this training data going back to the 1890s, and we get our models sort of all set up and calibrated, and then we run the clock backwards, how good at it is it at figuring out or guessing a backwards extrapolation? It's really good. Like, it's right on the line. So when you run the model forward, you can't say with 100% certainty, all right, we got a pretty tight line instead of a cone going forward, but you're also not getting a uselessly wide cone out from 2023 like this, right? If we're graphing temperature, for example, you're getting a line like, or a cone like this. Okay. Now, and so, you know, you get statements like, when you get into the more detailed modeling documents, the 3,000-page report instead of the 10-page summary report for everybody, you get very specific descriptions of how fat or skinny is that cone. They keep getting skinnier and skinnier, to the point that they basically look like this. And from here, it's like, well, I'm trying to run Glacier National Park or White Sands National Park. I don't even care what the specific sort of angle of that cone is. I just need to know kind of what's the right ballpark, you know? So this is, in the field, what we call kind of a research or scientific application versus a managerial application. Like, if you are leading warfighting efforts, for example, you don't need to know the precise location of every single one of the enemy elements. You need to know where they are sort of clustered. You need kind of the center of the mass, because that's where you send the cluster bombs, right? And just wipe out the whole area. Or something like that. I don't know. I don't do fighting people, I guess. Anyway. Directing assets down range, going kinetic, whatever, I don't know. Anyway, so the idea is, what's kind of the ballpark, you know? And with RCT 8.5 and these other sort of business as usual scenarios, we have this, right? We don't know exactly how things are going to be 60 years from now in a particular place, like down to the specific weather that day, but we got a real tight cone around the picture for each 1 kilometer square. Okay, so
It's just like,
at that level, we can
it's
just
hotter and wetter. I don't know how we would plan or response to a place that's dependent on cold spring water. You know, what would you plan, you know?
So if it's going to be wetter and it's a spring-fed area,
There'll be floods.
yeah.
How, what
So
would
they're
you
going to
plan
be floods.
to, you know, what would you plan to combat though? I mean, you know, the area, it's nothing but valleys there ain't much, you get a flood coming, there ain't nothing, it just floods,
Yeah, pretty much.
you know?
So that's part of your answer. It just floods, right? We have some really heavily channelized areas, meaning, you know, steep bluff walls confining the current or the Jack's Fork or both rivers in certain spots, and it's never not going to be flood prone in those areas. So that's the plan. When it floods, right? It's like that Draco guy in the old Rocky movie. If he floods, he floods. Okay. And that's all right. That's a valid answer, right? So what does the Park Service do now when Ozark Scenic Riverways is well above flood stage?
Shut the park down. Or
Shut the park down. Yeah. You call it good. It's like, you know, we can't ask this riverine system to do something outside of what it's just automatically going to do. So we gotta plan for that and respond to it and just be okay with it when that happens. And work with stuff like the concessioners, for example. Part of the plan might be, hey, you guys have to, you know, to put your float craft on the river for the coming year, you guys gotta pay us, I don't know, 50 cents per canoe, just to support the cost of administrating the river or whatever. But we're not going to charge you for reservations at 50 cents per boat, for reservations where, you know, the system's flooded out. Like, that's not your fault as a concessioner, and we're not gonna extract money from a trip that can't happen safely. So you make it okay for them to have to shut down as well. Nobody's happy about it, but, you know, you can at least sort of take your foot off of their neck a little bit. Stuff like that. Not that we want to have our foot on the neck of our concessions. We want to work with them as equal partners and co-stewards of this land. But you know what I mean. Okay, that's a really good question, right? So for stuff that's just going to be dramatically different or more deleterious, what are we going to do about it? And maybe in a few of these places, maybe that flooding isn't pure catastrophe. So for those of you who went on our trip, and Gary, you know this as well, this semester, our field trip, we saw like thousands of acre feet of gravel choking off that water channel. What's the only thing that's gonna move those tons and tons and tons and tons, millions of tons of basically rock trash eroded into that waterway from clear cutting and over farming over the last couple centuries? Floods, right? So maybe we're not even sad when it's flooding like real hard sometimes. Yeah, maybe it's wrecking a bridge or two. Okay, we'll deal with that, right? We know how bad these floods can possibly get. Our fluvial morphologists, channel morphologists, our hydrologists, and our civil engineers, they can work together. They have really good models for how high do we need to set this bridge. And it might be a pretty major construction project, but water isn't doing anything creative, it's just flowing downhill, right? So we can handle that. You know, we just set the design spec to handle the 10,000 year flood instead of the 500 year flood, and good to go, right? It's gonna be a kind of a bomb-proof bridge, but it's not a bad thing. And then for everything else, it's gonna get colon blasted out, right? And that's kind of how it should have been all the way through. But we had all that sycamore and elm and river birch and stuff locking all that gravel in place. So let's scour the bowels of the river and flush it on down to the Mississippi Delta. So, long answer to your question, but, you know, figure out what the impacts kind of look like. If the glaciers are all melted, okay, they're all melted. We can't stop that necessarily, and we're probably not going to. What does that mean? It means a radically altered water supply for everything downslope. So Michael has an opportunity here to take a look at the ecosystems the mountain valley ecosystems of the places where its climate is going to shift toward, and be like, okay, so do those valley ecosystems support the large migratory wildlife, the ungulates, elk, bison, whatever? Do they support what we currently have? Not so much. Do we need to start thinking about not just preserving, but moving or steering our glacier valleys towards climate resilience? Let's get ahead of it. If we know that this is going to become Dall sheep territory, mountain goat territory, more than it's going to be elk territory, okay? Maybe we pump the brakes on our elk reintroduction efforts here over the next 25 years, right? We're talking large timescales. Then let's populate some Dall sheep. They'll help move this ecosystem into the shape it's going to be in. So might as well get ahead of the curve. We can do stuff like that. Other thoughts, other questions? Is anybody, and it's okay if you are, just totally drawn a blank on park? I saw a temperature number and a rainfall number, but like, I don't know what that means. I've never been to any of the cities that were identified as what the climate is morphing towards, so I don't know how to visualize it. Anybody drawing a blank? That's okay. This is a collaborative final exam. As you guys are thinking and writing on outcomes and plans and responses, I'll put some more short video clips on screen to maybe, hopefully, kind of jog your thinking. Storm events are going to be more intensified, right? Already we have some areas getting hit with hurricanes more frequently. Tokyo, a couple years ago, got hit by, I think it was, 2 Category 4 hurricanes in like 10 days or 12 days, something like that. They got walloped twice in a row, which is pretty unusual now. Less unusual then. Okay. Does your park have any historic old stick-built lodges like El Tovar at the Grand Canyon or any of the big ones at Yellowstone that might struggle with intensified electrical storm activity? That's going to be a thing in certain places. What about your infrastructure? Do you have a lot of gravel roads? Are they all paved? Are any of those roads, like at Rocky Mountain National Park, are they high elevation, where the freeze-thaw cycling is going to be a little bit closer to the absolute trash fire that is happening at Denali National Park? The one park road, it's about, it says 92 miles here, goes through the middle of Denali National Park and just sort of slices the millions of acres of wilderness kind of in half, north-south-ish. And that gravel road gets frost heaves, you know, in spring and autumn as the temperature is going above freezing and below freezing on a daily basis. Above and below you get frost heaves. As the water in the surface soil freezes and expands, it can heave the soil and grow ice crystals as hoarfrost, as it's called, H-O-A-R, frost, up out of the ground or sideways out of like steep slopes, for example. If you go hiking in the Shawnee in January, maybe right before classes get started again, you might see they look like almost like tiny little ferns as they're just sort of poking their fiddleheads out of the ground. That's a frost heave. It's actually really beautiful in small scale. In Alaska, where they're having crazy temperature fluctuations, remember those plus 70-degree temperature anomalies, Alaska is part of the area getting those. Those frost heaves are not 6 centimeters, they're 6 feet. They are 2 and 3 meters long. And where the frost heave intersects with the road, imagine a section of 13 in town getting jacked up 6 feet straight up. And cars like driving to that spot and being like, well, I guess I'll just die then, because like you can't drive over a 6 foot tall speed bump. That's what the infrastructure, basically the road maintenance crew at Denali National Park deals with. So the Park Service spent something crazy like, it's like $25 million or something like that on, a $53 million plan, a $53 million tax dollars plan to build a section of road. It's like 0.2 of a mile long in one particular spot where it sort of wraps around sort of a side slope going up to one of the ridge lines, and the frost just like jacks or pistons sideways out from there and just shoves the entire road down the slope. It's crazy looking. If you know what piston blocks are in Minecraft, imagine 6 foot long piston thrusts for your road blocks in Minecraft. Okay, not in my Christian Minecraft server, but just hypothetically. Okay, so $53 million to fix a 0.2 of a mile long section of road. Make it frost proof. Does your park have any roads, campgrounds? Hell, Rocky Mountain National Park is an entire visitor center at 11,000 feet. So, what's your plan? Those frost heaves are coming, right? You shut that visitor center down? Do you jackhammer out that road and be like, we can't fight this? Do you double down and spend a couple of $100 million to repave Skyline Drive, as it's called? The highest elevation highway in North America? Or do you do something else? Do you turn it into a hiking trail and be like, this isn't a problem, it's an opportunity? Yeah? Rebranding. All right, now's a good moment. Just kind of while we're cycling through this stuff, if you need to take a quick break, get some water, use the restroom, stretch your legs, get your blood flowing again, and we'll finish up for the semester.
Was there anything I missed in the first 30 minutes of class?
No, it was
Okay.
basically just this. It was literally just this, looking up everybody's city, or the city closest to everybody's park, just like we did with you, and talking through, kind of jumping right into the impacts. So, the premise is that we are, this speaks to my sense of humor, this speaks to my soul. The premise is that we're going with the business as usual climate forecast because that's the one that most accurately describes kind of the past 7 or so years since that model came out, or the most recent versions of that model. It's tracking very closely with just kind of economic growth, population growth, a couple of half-hearted attempts here and there to limit climate emissions. Well, not really, not practically speaking. So that's the event, that's the trajectory we're looking at. So this is an aggressively optically stabilized video. If you see how much the camera or the framing is kind of wobbling up and down, it's because the The fire is melting the asphalt, the tar and chip pavement, and it's like trying to drive through wet oatmeal. It can be quite dangerous. And it ruins the vehicle. Like, that stuff hardens onto the tires and the underbody, and you can't get it off without a torch. Pretty nuts. It's not all gloom and doom. All right. Until they mutate into brain controlling fungus. I'm kidding. They won't do that. But the business as usual model is carbon intensive recreation. So part of the conversation is, what's the carbon load or budget? This guy broke his face. He fractured his skull when he slammed into this thing. But the real story of this, just bro-tastic short video clip here is these guys spent a whole bunch of diesel emissions into the atmosphere for, a couple of hours of entertainment and a viral video. And for the next 80 to 116 years, on average, all the rest of us get to deal with the outcomes of those emissions. So, does your park have any sort of carbon-intensive recreation right now? Is your park, or at least certain uses of your park, part of the problem? And it's okay if the answer is yes, right? We don't want to sort of ignore that by any means.
So, what if there's like a whole military range right next to your park that are constantly like detonating like bombs and shooting stuff at it?
Yeah.
Do you take into consideration what they're doing with your park?
No.
Or is that just their thing?
Different pig, different farm. Now, the United States military is pretty clearly and far and away the single largest carbon emitting organization in the world. We are very, very, very carbon intense the way we run the American military. And it's also just a function of size, right? So we have a big military, a very big military. And we have the largest militaries, plural, right? So the largest Air Force is the United States Air Force. The second largest Air Force in the world is the United States Navy's Air Force, right? Naval aviators and stuff like that. The largest, I think it's still the largest army in the world, is
China.
it China now? Yeah,
I think it goes
By
China.
manpower, it's definitely China.
okay.
I think it goes China, India, then Russia, maybe less.
Okay.
I could be wrong with Russia.
So the Army, the United States Army, has its own naval force, mostly to move tanks around across rivers and stuff like that, for anything that's larger than bridge length. The Army has a big aviation unit as well, right? And so on and so forth. So it's a big carbon-intensive organization, but it's also outside the scope of what you're doing as a park ranger, right? That said, we gotta fix the United States military's sort of posture towards burning fuel. That said, working with the Department of Defense on ecological conservation is a dream. I'll tell you why. The United States military is in direct and complete charge of huge amounts of the American landscape, both domestic and abroad. And when they sort of figure out they need to do something, like protect endangered frogs at the Kanza artillery training area, where individual munition impacts in the tallgrass prairie set off these basically ring-shaped fires, and are doing prairie wildland fire controlled burns in a way. Each, send it.
that creates the perfect habitat for these frogs. And so the military was happy to be like, okay, so you need us to bomb the frog habitat into healthy function. And the ecologists were like, yes. And the answer from the army was, say no more. And so they did it, and it's this huge success story. And it was, everybody was wringing their hands like, my God, this is going to be so expensive for these dumb little frogs that are protected by the Endangered Species Act. What are we going to do? And, you know, most military folks, by and large, they're not trying to burn the whole world down. A lot of people join up because they want it to not burn down, right? So there's a lot of actually really responsible folks in the American military, and it's awesome to work with them because they have complete control over all of those bases, all of those training areas, and stuff like that. So if you can work it out with them, like you tell them what to do and they'll do it. Like they will do it to the nines.
And they're extremely well funded.
Yeah, $800 billion, just shy of $1 trillion a year.
I got a buddy that works for the Corps. That was the biggest difference between the Corps and the Forest Service.
Yeah.
You know, Corps under
Right.
the military budget, whatever they needed, it was approved.
Yeah. So one of my grad students worked with the Army Corps of Engineers right after graduating from SIU with his master's degree. And the Corps at Sardis Lake down in Mississippi, I think, they had some extra money, and it's use it or lose it funding. So they had like a 2 or 3 year old bulldozer that they were using for, you know, land management and stuff like that. And it's a whole bunch of basically water impounds for flooding control, flooding mitigation along Mississippi, if I recall correctly. So some big like water control projects, and you know they needed to spend some money, so they drained one of the lakes, drove the Caterpillar out there, drained it of all of its fluids, and just left it there. It's a 2-year-old bulldozer, like it's still usable. And they got a new bulldozer, you know, like that's how you do it. To leave structure in the pond, they weren't just like wasting it. Like they're helping the fish, guys. They're helping the fish by buying more bulldozers. Okay, securing American forest.
I was talking to one of the cadre at RTC, and he told me that some of the installations, they have, I think it's DNR, I want to say it's DNR, they have like 1 or 2 representatives that stay on base and they manage the land inside the base.
Yes, and that can be a civilian position if you don't want to join up. I was actually looking at doing that at some of the overseas bases, like in Kuwait and Okinawa and stuff like that. Like you can make a ton of money being like the recreation coordinator or something like that, right? It's a bunch of forestry stuff.
Yeah, every base also has like an environmental office that like manages like wildlife and tries to make sure that we're not harming wildlife as much as possible. I think every military base is like protected bird habitat or like a wildlife refuge basically. Like you're never supposed to mess with wildlife on bases.
Cool. I did not know that. Cool. It makes a lot of sense though. I mean, you guys have to use a ton of land to do what you're doing, and most of its habitat, like it's not continuously overrun by humans, right? So, does that help answer your question? Yeah. Cool. That's a really good question.
I also looked up the most powerful air forces.
Huh?
And it's the Air Force, the Navy, then the Russian Air Force, and then the Army, and then the Marine Corps, and then Indian Air Force.
So we're 4 of the top 5 most powerful air forces in the world.
Yep.
All right. At least until the EMPs start going off. Got it. All right. Other questions? Yeah.
I mean, going off of that, I think that the U.S. has like 11 aircraft carriers, and the next under us is China with 3, I think. And those, I got no clue how much they cost.
They are catching up fast. Very fast.
The Chinese and the Russian Air Force or aircraft carriers are diesel compared to ours, they're nuclear.
Yep.
they have like a significantly smaller range and self-sustainable light out at sea.
Yeah, and I'm aware that the Chinese military has some real problems with metallurgy quality control. They're about 30 years behind us. And so industrial espionage is a very, very, very active area. But they have triple our war material building capacity. So they're behind us, but they're going to overshoot us at some point. And overshoot is the wrong word. Overtake, maybe, is a better word. But yeah, it's coming. I just want to apologize. This is not a super uplifting and exciting class session, but it's an important one. So I appreciate you guys being willing to jump into some of this stuff. Like, do you remember in 2020 when we were pretty sure it was going to devolve to a Mad Max world in a couple of years? And here we are? Yeah, it's not that bad. I mean, it's going to get worse in 2142, but... All right. Other questions about impacts at your park, as best the forecast can tell it? Questions about how you might plan or respond to those impacts? Questions about evaluating the interface of those impacts and your plan as clear-eyed as you can in terms of outcomes? I want to encourage you guys that over Monday and today, you guys have been asking a lot of the right questions, right? So this exercise is going really pretty well from my perspective. Whether or not it feels like it's total chaos for you or not, it's actually going really well. Okay. So for high carbon recreation, I have a couple of different videos, and most of the highest carbon impact things are going to be motorsports, and among those, anything that involves airplanes. Airplanes are huge, huge, huge per pound carbon emitters. So anything with skydiving, any kind of aerial stunts around parks, stuff like that, you may have to clamp down pretty hard on that in your plan. This graph blows my mind. Think for a minute about the sort of individual user scale of climate impact of how we tend to do forest and outdoor recreation, how your visitors tend to do forest and outdoor recreation, kind of person by person. Right, so imagine your typical visitors doing your typical activities in your park on a typical day. Are they wearing a bunch of plastic clothing? Did they arrive in an RV pulling a toy hauler full of additional internal combustion engines? Did they get food? Let's see if I can find that here. Did they get food locally? Or how much carbon did they spend just to eat? So right. How many food miles of carbon are attached to one of these little Dole mixed fruit medley cups? Some of these are traveling close to 15,000 miles because it's slightly cheaper to have somebody else pack it. Okay, cool. So, can the people at your park eat locally? Is that even possible? Or does the scale of recreation at your park completely outstrip the human carrying capacity, the food generation capacity, maybe the sewage processing capacity at some Alaskan parks, etc.? The amount of fresh water present, right? So at Grand Canyon, there's a huge logistical problem. There is one pipe that pumps water up from the Colorado River up a vertical mile and feeds it to South Rim Village. And that pipe is constantly bursting, constantly, like up to a couple of times a day. So you gotta go send your arc welding crew out to the spot. Might be on a cliff face, halfway down a 300 or 400 foot cliff face, with welding gear and safety harnesses and pipe sleeves, patches, stuff like that. Like, that's a lot of water pressure. It's a lot of hydraulic head, as the fluvial morphologists would say. Hydraulic head is the amount of pressure based on water height or depth. Cool. Any other questions? Does anybody need more time? All right. We don't need to prolong the agony any more than you guys need. So, if everybody is pretty comfortable with where you're at, then let's pack it in a few minutes early. And let me just say thanks for an interesting and fun semester. We had a blast on the field trip. You have until the end of our final exam day, so 11:59, close of everything on Friday, December 15th, I believe it is. To turn in anything that is remaining. But would encourage you to push out whatever you have left to do in this class sooner rather than later, and then forget about it, right? Move on to your other exams, study for those, get ready for next week, and best of luck to you on those.